Hello and welcome to Psychology 1, and this particular video is going to be on part 1 on states of consciousness. Now, consciousness isn't something we generally think about. However, in this chapter, we're going to look at the different states of consciousness. In this particular part, we're going to focus on sleep as the voluntary state of conscious. It's involuntary. If I said voluntary, I meant involuntary, because if you choose not to sleep, at some point sleep will come over you anyway. It's a required state of consciousness, but it's involuntary. And in part 2, we're going to look at voluntary states of consciousness. Let's consider this. In 1987, Ken Parks of Toronto drove 20 miles from his home to his wife's parents' home, where he bludgeoned his mother-in-law to death and attempted to choke his father-in-law to death. However, the father-in-law survived. Seemed like a typical sort of crime. However, Ken was asleep and was sleepwalking and was thus acquitted of murder. And this was in 1989 and upheld in the Supreme Court in 1991. Now, in this chapter, we're going to examine the levels of, gradation of consciousness when we are not fully awake, alert, and aware, or perhaps of sound mind even. Now, remember, from last week, the case of Jean-Dominique Bauby. After his stroke, he went into a coma and a unique altered state that not many people experience. Yet during this state, Bauby still had some awareness of his surroundings. Now, there are two different altered states, in this instance, sleep and a coma. The study of consciousness doesn't come easy in the history of psychology. Both William James and John Watson insisted that consciousness was not a proper area of study, as scientific methods could not directly observe or measure another person's consciousness. Now, the past few decades, we've seen a cognitive revolution, and thousands of psychologists now believe we cannot capture the richness of the human experience without referring to consciousness. We are flooded with studies of consciousness by psychologists, biologists, neuroscientists, physicists, and even computer scientists. And even though we still cannot directly observe the consciousness of another person, psychologists who study consciousness study it through self-reports and physiological measures and new technologies that in some way permit our observation of events such as neuroactivity in the brain. Now, it's really important to note that from last week, we looked at how we sense and make sense of the world around us, sensation and perception. Now, we cannot make sense of all sensation at one time. Therefore, everybody selects some sensory information and delete others. And it's through our life of sensing and perceiving we tend towards things we are familiar with and already make sense of. Our past experiences, people we associate with, choices that we've made, goals and dreams that we've all had, these all influence each of our perceptions. So as we move into this chapter on consciousness, consider these questions. If we all sense and perceive things differently, our past experiences are different, our family and friends have been different, the activities that we've engaged in are different, are we all sharing a shared consciousness? Or are our consciousness completely unique? And if so, what are the implications? So let's start exploring what is consciousness and what it means to be conscious. Now, a couple of definitions first. Consciousness. This is the awareness of the external events and internal sensations, including awareness of yourself, your thoughts, about one's experience at any given time, moment to moment. Now, of course, We're not constantly and continuously aware of all waking time. We hem and haw regarding what we focus our attention on and what we attend to. Thus, we have a varying degrees of awareness from moment to moment in any given time. So first, we can consider consciousness as sensory awareness of the environment. When we pay careful attention to one thing, we cannot pay equal attention to everything else or anything else. If one was to, let's say, maybe have a disorder, some instances of autism is about paying attention to all sensory information, and it gets extremely overwhelming. Instead, we're exhibiting what is known as selective attention. That is, we focus on a particular stimulus. Adapting to our environment involves learning which stimuli must be attended to and which ones can be safely ignored. So, for example, when we're driving, you are selecting what is most important to focus on. The lane you're in, the cars that are around you, pedestrian speed, weather conditions, rather than things like your phone or organizing your glove box or shaving. Now, there is a term that's often used in psychology for things like consciousness, and that's the cocktail party effect. And this is the phrase that's used to describe the phenomenon where we can pick out the speech of a single person across a room at a cocktail party, especially when you hear your name among the many people talking. So various stimuli can capture our attention. Some of the other ways that our attention is captured is through sudden changes. If you're in a warm room and it's sweltering and a cool breeze comes through, you'll notice that. Novel stimuli. You're in your classroom and a dog enters it. That's unusual, that's new, that's novel. So you notice it. An intense stimuli. When bright colors emerge, you notice the brightness. Repetitive stimuli can affect our consciousness. The same TV commercial played a dozen times draws our attention, unfortunately. Now, secondly, we can also consider consciousness as a direct inner awareness. Now, direct inner awareness involves being aware of thoughts, images, emotions, and memories. Perhaps you've crammed for a test, and while writing the test the next day, you get stumped by a question. And yet you stop and think, and you can think you can even see the page it was on, the page number, even where on the page it was. You just can't remember what the answer is. Now, while you imagined the book and you were, when you were studying, you were conscious of the image through direct inner awareness part of why and this is partly why cramming is not the best preparation strategy. Now, looking back into some history, Sigmund Freud proposed 3 levels of consciousness. He proposed that there was consciousness, which was the awareness of our environment. There was pre-consciousness. This is this material that is not currently in our awareness, but it's easily available. Now, these can be accessed through prompts and cues. You don't have to have all your class content in your consciousness all waking time. You can access this information via tests or questions being asked. Those questions on multiple choice questions or on tests are really prompts and cues to remind you. And then the third is unconscious. Now, material is unavailable to be aware of under most circumstances under unconscious. Now, Freud believed that we use repression to reject feelings of guilt, shame from our conscious awareness. Now, this is done automatically and unconsciously. The other term that he coined was what was known as suppression, is when we consciously reject unwanted events or emotions or feelings from our awareness. We push them aside. Now, a fourth term was explored, known as non-consciousness. And this is the process where we cannot experience through our sensory awareness. The firing of neurons, for example, we aren't aware of. growing our hair. We don't feel it happening. So there are these non-conscious activities. Now, there are stages, and you've probably heard and are familiar that there are stages of sleep. And we'll look at stages of sleep and dreaming. Now, sleep has function. It must have some function. If we're having to do it involuntarily, there must be a reason why we sleep. So when we think of functions of sleep, 1/3 of our adult lives is spent in sleep. Experts recommend about 8 hours of sleep a night. Now, newborns need much more sleep than adults, so partly their reason is brain development. So why do we sleep in adulthood? What's the function does it serve? Well, we all probably had experiences of several all-nighters or a few days of very limited sleep. You probably noticed the result. Perhaps you were grumpier. Your cognitive skills or your memories were diminished. Given the amount we sleep, researchers can state how sleep is restorative. It aids in our learning. It consolidates some of our learning, and in infants, it supports their brain development. So researchers really don't have our function of sleep all figured out. Given how much we do of it, you'd think they would. But there is a system that looks after sleep and awake functions in our body. The circadian rhythm is a cycle that is connected with a 24-hour period of the Earth's rotation. Now, our brain, more specifically, is a very small bit of tissue. There's a very small bit of tissue located in our hypothalamus, and it's called the suprachiasmatic nucleus, aka, also known as, the biological clock. And it's the regulator of the daily fluctuations of our body functions, and it's known as their circadian rhythms. The circadian rhythms is a regular fluctuation of certain body functions from a high point to a low point within a 24-hour period. Now, two rhythms are highly relevant to sleep and are the sleep-wakefulness cycle and body temperature. Now, our eyes are important here. When the sun goes down or is rising in the morning, the available light enters our eye and activates our photoreceptors, and then travel to the optic nerve where the impulse goes to the suprachiasmatic nucleus to stimulate the release, or not the release, depending upon dusk or dawn, the hormone melatonin. It stimulates our sleep. Now, light is not the only factor that affects sleep. There are some external factors that can also affect our sleep. Two come to mind are known as jet lag. Now, if you've ever experienced this is the effect that we have in our circadian rhythms when the sunlight at different times when you're used to. That is, it affects your sleeping and therefore alertness and functioning. In other words, being awake when your biological clock is trying to sleep. The second type is known as shift work, and some of you probably have had this, are rotating shifts, trying to be alert when your circadian rhythms are shutting us down, or trying to sleep when it's trying to wake us up. This can cause sleep difficulties, digestive problems, and lowered alertness and efficiencies, productivity, and safety during work periods. So what can we do to reduce the effect of shift work? Healthy diets, regular exercise can help. Moving work schedules forward from days to evenings to nights make adjustments easier. Rotating shifts every 3 weeks can lessen the effect on sleep. Researchers are investigating devices like a light mask and medication to help, but there's nothing conclusive yet. Now, if we're continuing on with the stages of sleep, then in every sleep there's a cycle of sleep. Sleep research started somewhere in the 50s in an effort to understand what goes on during sleep. Now, research would unveil some new information. Sleep was found not to be dormant time in our brains. Your brain doesn't sleep. In fact, it's like awake time. There are brain waves during sleep. Now, brain waves, there's some terms we should be familiar with. Now, one term is frequency. Brain waves go in a frequency. That's the number of waves per second. And now that will vary, of course, according to what type of activity in the brain. And then there's amplitude. That's the height of the wave. And there's an index of strength, high frequency associated with being very awake. Now there are also several types of waves, brain waves. There's alpha waves in the brain, which are 8 to 13 cycles per second, theta waves, which are 6 to 8 cycles per second, and delta waves, which are 1 to 3 cycles per second. Now, when we think in terms of the stages of sleep, we can begin to, when we start into our evening of sleep, we begin to relax. Our brain emits alpha waves. That's a low amplitude, 18 to 30 cycles per second. The first 4 stages of sleep are what's known as NREM sleep, or non-rapid eye movement sleep. The 5th stage is called REM sleep, rapid eye movement sleep. So let's go through the stages a bit at a time. We'll sort of overview it. Stage 1, brain waves start to slow down from alpha waves and enter a pattern of 6 to 8 cycles per second called theta waves. Now the hypnagogic state, we may experience brief dreamlike images in that stage. Stage 1 lasts about 30 to 40 minutes. And then we enter into stage 2, where brain waves slow even further down to the 4 to 7 cycles per second. There's also some sleep spindles occurring here, and sleep spindles are brief bursts of rapid brain activity, 12 to 16 cycles per second. Now, stages 3 and 4, brain waves slow down to even fewer frequencies, 1 to 3 cycles per second, and this is called delta waves. In stage 3, and it slows even more into stage 4, down to 0.5 to 2 cycles per second. Now, it's difficult to wake a person in stage 4, which lasts about a half an hour. If you've ever tried to wake somebody, if you knew they were in stage 4, that would be difficult. Now, I've mentioned REM, or rapid eye movement. REM sleep, after moving through the 4 stages of non-rapid eye movement sleep, we begin a journey back upward through the stages until we enter REM, or rapid eye movement sleep. It's also called paradoxical sleep because the EGE, that's a way of measuring brain waves, looks like your brain is awake during rapid eye movement time. It's very, very busy. It's difficult to wake somebody in REM. If you do wake a person up, 80% of the time they report having a dream. And each night we tend to undergo about 5 trips through the stages of sleep. On average, we travel through these stages in about 90 minutes, and then we repeat the stages from 1 to 5 again. Sleep, learning, and memory. While the REM sleep and deep sleep are both connected to the consolidation of learning and memory, being REM deprived, that is, if you miss REM sleep for various reasons, it interferes with memory. And what's interesting, if REM is deprived, a person will experience what's known as REM rebound, where he or she will spend more time in REM sleep during subsequent sleep periods. So it must be very important that if we miss it, our brains and bodies regain and rebound to make sure we do get REM sleep in subsequent sleeps. Now, there may be times you feel in control of the dreaming. You know, when you're dreaming, and when you're thinking you're dreaming, you know you're dreaming. You can consciously sort of in your dream say, I know I'm dreaming. These are known as lucid dreaming. Now, there are theories of why we dream, but the theories are not definitive. Some of them are based on biology, and some are based on a more psychology-based. Now, we'll start with dreams as a residual of the day. Dreaming content is memories of the day gone by that tend to include people and experiences from our everyday life. It tends to include things that we are preoccupied with. Traumatic events can be spawned into nightmares. Frequent nightmare sufferers are more likely to have feelings of anxiety and depression. Now, dreams can be an expression of unconscious desires and wishes. Now, that's a Freud-based perspective. Freud theorized that dream content is unconscious wishes and urges that we may censor during the day. The content of dreams is symbolic of unconscious fantasized objects. Freud would spend time interpreting his clients' dreams. The third theory we'll call is activation synthesis model of dreams. Now, this theory involves a part of our brains called the pons and the neurotransmitter acetylcholine to stimulate a response that leads to dreaming. Activation of the reticular activating system, or the RAS, which arouses us but doesn't wake us up. The RAS also stimulates part of the cortex involved in memory, and the cortex then synthesizes, pieces together these memories. So dreams can help us consolidate memories. So you may be familiar that not everyone sleeps well as one would like, and we may have a sleep disorder. Let's look at 4 of the more common sleep disorders. Insomnia. According to the Canadian Sleep Society, 30 to 40% of adults are affected by insomnia in any given year. 10% have insomnia problems so severe that it interferes with daily functioning. Now, that phraseology there, interferes with daily functioning, is one of the conditions by which psychological disorders are diagnosed. Insomnia is a chronic difficulty in falling asleep, staying asleep, or maintaining a restorative sleep. Narcolepsy, that's the second sort of sleep disorder. It's a genetic disorder in which the person suddenly, without any warning, will collapse into REM sleep, deep sleep. It's incurable. There are medications that can be taken, and it is caused by an abnormality in the part of the brain that regulates sleep. It typically will last about 15 minutes. Now, this can be accompanied by sleep paralysis, a sudden collapse of muscle groups thought to be a disorder of the REM. Now, stimulants and depression drugs have helped. Now, I've had a student in my class one time with narcolepsy, and she brought a friend and a pillow, and every once in a while she'd start to go down while sitting in the chair, and her friend would put the pillow on the desk because her head was slammed down, and she'd sleep. You couldn't wake her, and then she'd wake up and she'd be fine again. Sleep apnea is the third. Sleep apnea occurs when a person stops breathing for nearly half a minute or more, followed by a gasp of breath. The major symptoms of sleep apnea are excessive daytime sleepiness, loud snoring, snorts, gasps, and choking noises while sleeping. Causes, may include anatomical deformities that clog the air passageways, and problems in the breathing centers of the brain, such as a thick palate. Now, it's treated by things like weight loss, surgery, continuous positive airway pressure supplied by a mask, and a CPAP machine. The last group of sleeping disorders that we're going to look at are sleep talking, sleep terrors, and sleep walking. Now, sleep talking can occur at any stage of sleep, and it's known as somniloquy. Now, often the talking makes no sense, so be careful of listening to a sleep talker and taking what they say as being accurate, true, and genuine. It often makes no sense. Sleep terrors occur during the first 2 sleep cycles and involve frightening dreamlike experiences that occur in the deepest sleep of non-rapid eye movement sleep. Sleepwalking, as was mentioned earlier, occurs about 7 to 15% of children and only about 1 to 2% of adults. Typically, people don't remember their excursions. though they may respond to questions while in sleepwalking condition. And, it's not, people won't die if you wake them up. Okay? So, there we go. Part 1 on states of consciousness, and we reviewed the altered states of sleep. Next week's video, we'll explore other altered states of consciousness. Where sleep is not voluntary, the next states of consciousness are choices that we can make that affect our consciousness. Okay? There we go. Part 1 on states of consciousness. Carry on the good work, everybody. Carry on. Bye now.